Hi everyone. We are going to start talking about trig today. And so today we're really going to focus on a new type of angle measure, a unit of measure called a radian. We'll do a couple of other things as well. But if you've ever cleared your calculator and then taken a trig test, we always tell you once you clear it, switch your calculator back into degree mode because it's sort of the default is radians. So we've never really told you what those radians are all about, but that is one of the big focuses of today's class. Okay, so we're going to start out just with a little bit of review from grade 11. I want to talk about what an angle is in standard position. It's essentially an angle that's drawn on the coordinate plane. Okay, so here's the coordinate plane, and here's our angle theta. Okay, so every angle has two arms. When something is drawn on the coordinate plane in standard position, the positive x-axis is called the initial arm. Initial arm. And the other arm, in this case this guy, is called the terminal arm. Okay, so there's our angle theta in standard position. The other thing that's important to know is that the direction that the terminal arm goes in is actually associated with a positive or negative sign to the specific angle. So if I take another example, here's my initial arm, and let's say the terminal arm is right here. Okay, if I go in a counterclockwise direction and look at the angle theta in the counterclockwise direction, then that angle is a positive measure. Okay, so theta is positive. We can also get to that angle from the initial arm going in a clockwise direction. And if we go clockwise, the angle is negative. Okay, so that's another sort of informational piece that is important to know. Okay, so now we're going to talk about this angle measure business. And up to this point, you guys have pretty much only measured angles in degrees, but we are going to introduce this new angle measure called a radian. So the two measures that we can use, the two units, are degrees or radians. Okay, one of the things that we're going to need to do is to convert between the two. Okay, so hopefully you guys are familiar with this. If you do an angle in standard position and rotate that initial arm all the way around, this angle will be 360 degrees. Okay, so that's one full rotation in degrees is 360. And this actually has ties to several thousand years ago when people were trying to understand astronomy. And they were looking at one revolution of the Earth around the sun. And so there's approximately there are 365 and a quarter days actually to do one rotation, which is why we have a leap year every 4 years. But they thought at that time that a degree was the angle at which the Earth revolves around the sun in one day. So this unit of measurement in degrees is very much tied to a place in history. In radians are a way to connect the angle measure to the circumference of a circle. So let's say we know circumference is 2 pi times r. One full revolution is 2 pi radians. whoops, 2 pi radians. Okay, and so essentially what we're going to be able to do is connect that angle theta in a linear way to, if the angle is 2 pi, 1 full revolution, we actually draw the entire circumference of the circle. But if we do less than that, we're not going to get a whole circle, we're going to get a sector of a circle, like a piece of pizza. And what this measurement in radians is going to allow us to do is connect that angle in standard position to the arc length of the sector. Okay, and in fact, 1 radian, we'll talk more about the conversion in a few minutes. It's approximately 57 degrees, roughly. 2 pi radians, obviously that's an irrational number. So I say approximately 57 because the conversion factor involves pi. So this is a rounded value. Okay, so what this actually is, it's about 57 degrees. Okay, so that looks like it's about 57. I'm not measuring, I'm just estimating. Okay, and it's actually the angle, if this is the radius of the circle and this is the arc length, it's the angle at which A equals R. The arc length is equal to the radius of the circle, and that's what 1 radian is. Okay, we're going to come back to arc length in a little bit, so more on that later. What I really want to focus on for now is just how to convert between the two. That's what we're going to spend most of our time dealing with today. But essentially, 360 degrees is equal to 2 pi radian. Okay, or 180 degrees is equal to pi radians. Okay, and it really has to do, we're going to look at all of these different angle measures now. It has to do with a proportion of a rotation around the circle. Okay, one other thing just around units. For degrees, you must have the little like circle symbol. Okay, for radians, you can write RAD, or you don't actually have to put units in at all. Okay, so if you see an angle that does not have any units, that angle has been measured in radians. Okay, so what I want to do now is just show you guys some of the common angles that we look at in degrees and radians, and we're going to draw some of these too, not all of them. But what I want to do first actually is let's just draw a coordinate plane, and we're going to look at 1 revolution. So over here, let's do degrees first. We're at 0 degrees. This would be 90 degrees, 180 degrees, 270 degrees. Okay, now in radians, I'm going to do the radians in a different color, I think. Okay, this is still 0 radians. I'm going to leave the units out here so that it doesn't get too crowded. This would be 2 pi radians. So if 1 revolution is 2 pi, half a revolution is going to be pi. Okay, between 0 and pi, we're looking at the 90 degree angle now, is half a pi, or pi over 2. And then between pi and 2 pi's, right in the middle of pi and 2 pi's, is 1.5 pi's, or 3 pi over 2. So think of each quarter rotation as being half a pi, or pi over 2. Okay, all right, let's go back to this chart. Okay, so I'm going to do this in terms of rotations first. 360 degrees is 1 rotation. Okay, 180 is half a rotation. 90 is a quarter of a rotation. 60 degrees, well, 60 over 360, what proportion of a rotation is that? 60 over 360 is 1/6. So this would be 1/6 of a rotation. 45, let's see, that's eighths, because there's, the quarter would be 90, so 45 degrees would be 1/8 of a rotation. 45 over 360 is 1/8. And then 30 degrees, 30 over 360 is like 3 over 36, 1/12. And finally, 1 degree is 1/360th of a rotation. Okay, and that's what I was talking about before, where 1/360th of a rotation is approximately 1 day of the year, because there's 365 days. Not exactly, but pretty close. Okay, all right, so in terms of the radians, remember every quarter is a half a pi. So 360, that's 4 quarters, that's 4 halves is 2 pi. Okay, 180 is 2 quarters, so 2 halves is 1 pi. Okay, 90 is half a pi. Okay, I'm going to actually do some of these other ones. I'm not going to go exactly in order. 45 is half of 90. So half of pi by 2 is pi by 4. Okay, 60 degrees. So that's 1/6 of a rotation. If 1/6 of a rotation is or 1 full rotation is 2 pi, 60 degrees is going to be 1/6 of a rotation times 2 pi. And that's like 2 pi over 6 or pi over 3. Okay, 30 degrees will be times, this is 1/12 of a rotation, 1/12 of 2 pi. So that's 2 pi over 12, pi over 6. Okay, and then 1 degree is 1 over 360 rotations. 1 rotation is 2 pi, so that's pi over 180 radians. Okay. Okay, so these are just some of the common angles, but we're going to talk about how to convert all angles right now. Okay, the conversion factor does involve pi, and so a lot of the times what we're going to end up with when we do these conversions are irrational values that are written in terms of pi, and most of the time what's expected is the exact value. So you need to kind of keep that in mind, because sometimes you can just plug it into your calculator, but oftentimes you can't. Okay, all right, so converting units of measure. So what I want to remind you guys of is unit analysis, which we actually covered in Math 10C, and you've probably seen it in your science classes as well, because particularly in physics, unit analysis is almost like a strategy to solve problems. So the key is 2 pi equals 360, or if I have that, pi equals 180 degrees. Okay, pi radians is equal to 180 degrees. Now, if we take these two values and put them into a ratio, we could look at that ratio as being pi radians over 180 degrees, or 180 degrees over pi radians. And in fact, the value of both of these proportions is 1, because they are equivalent to one another. They're given in different units, but they have the same measure. Pi radians is equal to 180 degrees. And so when we're converting units, we can multiply by either one of these and end up with the same value in terms of the angle. Now, the key is that when you're switching units, you want your original units to sort of go away or disappear, and you want the new units to be left. And so what we're going to do is we're going to multiply by whichever version of this conversion factor cancels the original units. So if we want to convert from degrees to radians, we want degrees to cancel. So this is what we're going to multiply by to convert to radians. Okay, if we're in radians and we want degrees, we want the radians to cancel. So we'll multiply by this to convert to degrees. Okay, and we're going to look at what this looks like. If we have 120 degrees, for example, and we want to convert that into radians, we want our degrees to cancel. So what I'm going to do is I'm going to multiply by the conversion factor that has degrees in the denominator. Pi radians over 180 degrees. Okay, now the degrees cancel. So essentially what I have is 120 pi over 180 radians. Okay, now 120 over 180 is 2/3. So those values we can simplify, and that makes 2 pi over 3 radians. And that's again because 2 over 3 is equal to 120 over 180. Okay. If we're doing this with 300 degrees, we're also going to multiply by the same conversion factor because we want degrees to cancel. So pi radians over 180 degrees. Okay, and essentially now the pi is going to be left. Nothing to cancel with the pi, but the 300 over 180 is 5 over 3. So this works out to be 5 pi over 3 radians. Okay, here's a few others. Convert each angle into radians. So same idea here. We want the exact value. I'm going to multiply by pi radians per 180 degrees. Degrees cancel. Think in terms of reducing what's 150 over 180. It's like 15 over 18. So that's 5 over 6. 5 pi over 6 radians. Okay, and negative 270, again, multiply by pi radians over 180 degrees. So 270 over 180 is like 27 over 18, 3 over 2. So that's negative 3 pi over 2 radians. Okay, in this second example, we're asked to convert to the nearest tenth. Okay, so to the nearest tenth, this is where we plug into our calculators, still multiply by pi radians per 180 degrees. But now what you can literally do is on your calculator, you can, and I'm just doing this off to the side, put in negative 20 times times pi divided by 180. And I'm getting a value of negative 0.349, or to the nearest tenth, I suppose, negative 0.3 radians. Okay, 360 degrees times pi radians over 180 degrees. 360 over 180 is 2 pi radians, which is 1 revolution. And I know that one off the top of my head because I know pi is 3.14, so 3.14 times 2, or approximately 3.14, is 6.28, so that's to the nearest tenth, 6.3 radians. Okay? Okay, let's go the other way. So now we're converting from radians to degrees. Now what we want, and notice, by the way, there are no units in these two angles. When there's no units, you know you're in radians. Okay, so just to show you that the units do cancel, I'm just going to add that there so that we can very clearly see it. Now I want to multiply by the other conversion factor, this one over here, because I want the radians to cancel. So I'm going to do that. I'm going to multiply by 180 degrees over pi radians. And essentially you want the original units in the denominator. Okay, so what happens now is the radians cancel, the pi's cancel, And then 180 over 6 is 3. So that's 180 over 6, sorry, 30. So that's 7 times 30, 210 degrees. Okay, and here we're going to do the same thing. Multiply, this is in radians, multiply by 180 degrees over pi radians. And here, because there's nothing to cancel with the pi, it says to round to the nearest tenth where necessary. So I'm again going to enter into my calculator negative 1.2 times 180 divided by pi. And I'm getting 68.8 degrees to the nearest tenth. Okay? All right, some terminology. The principal angle. The principal angle, theta, is the smallest positive angle. And this is for an angle written in standard position. From 0 degrees to 360 degrees, okay? Or from 0 radians to 2 pi radians. Okay, and essentially what this is all about is, let's say we're looking at this angle. Okay, so I'm going to do 1 revolution, and then I'm going to do an extra. Okay, and let's say that this over here is 30 degrees. Okay, the angle that I drew, that sort of swirly thing, is actually 1 full revolution, which is 360 degrees plus 30 degrees. So this angle theta is 390 degrees. Okay, but the principal angle would be 30. Okay, and in fact, 30 degrees and 390 degrees, what we call those two angles, they're not exactly equivalent because you have to do the whole extra revolution to get to 390, but what they're called is coterminal because they have the same terminal arm. Okay, and what will transpire, and we'll see this later on, is that all of their trig ratios are going to be equivalent when they have the same terminal arm. Okay. Reference angle. So I'm going to talk about this really quickly because you looked at it in 20-1 and we're really not going to come back to it until our second or third lesson. But the reference angle for any angle in standard position, I like to call it theta R, or some people call it RA for reference angle, but it's the positive acute, I think it's just 1, yeah. No, it's 2, sorry. I gotta fix my spelling. It's the positive acute angle between the terminal arm and the x-axis. Okay, now this is going to look different in every quadrant. So in quadrant 1, that's theta. The acute angle between that arm and the x-axis is the exact same angle. Okay, so nothing sort of interesting in the first quadrant. In the second quadrant, there's theta. Here's my terminal arm right here. The angle between the terminal arm and the x-axis, the acute one, is this one. Okay, now how can we use one to find the other? Well, the two of them add up to 180 degrees. And so to get theta R, we can take 180 degrees and subtract theta. Or now that we know in radians, we can take pi radians and subtract theta. Okay? In the third quadrant, the reference angle, here's the whole angle. The reference angle is this guy here. It's the angle between the terminal arm and the x-axis. Okay, and with this angle, essentially the angle itself, theta, is equal to 180 plus the reference angle. Okay, and so to get that reference angle, we can take the difference between the entire angle and subtract out this 180 degrees that just gets us to here. Okay, so imagine that this was, I don't know, 210 degrees altogether. There'd be like 30 degrees from the terminal arm to 180. So it'd be like 210 minus 180, for example. Okay, or in radians, it would be theta minus pi. And then finally in the fourth quadrant, okay, here's our angle. Okay, theta. The reference angle is this guy here. Okay, and in this case, the reference angle and the angle itself add to 360 degrees. So to get the reference angle, we can take 360 degrees and minus the angle itself, or in radians, 360 degrees is 2 pi radians minus theta. Okay. All right, more terminology. So coterminal angles. I briefly mentioned this earlier, but angles are coterminal when they have the same terminal arm. Okay, so for example, I gave you this would be 390 degrees and 30 degrees. Okay, those are coterminal. And essentially coterminal angles, you can get coterminal angles by just doing more and more and more rotations of 360 from the principal angle, right? So if I start at 30 degrees and I do another rotation, I'm gonna have 30 plus 360. If I do 2 rotations, I'm gonna have 30 plus 360 plus 360, and I still end up in the same spot. So there are infinitely many angles that are coterminal to a particular angle. And on that note, we can for any angle in standard position, write the angle in general form. The general form includes all coterminal angles for a specific principal angle. Oh, not principal, sorry. Principal. Okay, so to get those coterminal angles, essentially what we do is we keep adding or subtracting. Whoops, I meant to do subtraction. Full rotations. Right, so that would either be 360 degrees or 2 pi radians. Okay, so the format for the general form is we take the principal angle and add or subtract 360 degrees times n, multiples of 360 degrees, where n is an element of the natural numbers, right? So we can't add 1.3 rotations because then you end up somewhere else. But we can add 1 rotation or 2 rotations or 3 rotations, etc. Or subtract. We can go clockwise. Or in radians, it would be p plus or minus 2 pi n, where n is an element of the natural numbers. Okay? So as an example, for each angle in standard position, determine one positive and one negative angle that it's coterminal with. So just add or subtract multiples of 360 or 2 pi. So for example, 270 degrees plus 360 degrees is 630 degrees. Or 270 degrees minus 360 degrees is negative 90 degrees. Okay, so I'm just adding or subtracting a full rotation. Now, when it's in radians, negative 5 pi over 4, we're going to be adding or subtracting 2 pi. So what I like to do is look at the denominator of my principal angle and turn 2 pi into the same denominator, right? So this would be 8 pi over 4, because 8 over 4 is 2. So what I'm going to do is start with this and add 8 pi over 4. And then I can add these because they have the same denominator. So that's 3 pi over 4. Or subtract 8 pi over 4. And that is negative 13 pi over 4. Okay, 740 degrees. Well, let's start with subtracting. That is 740 minus 360 is 380 degrees. So that's subtracting 1 rotation, and I get to 380. I think I'm going to have to subtract 3 rotations to get below 360, because after 1, I'm above 360. So I should really have degrees on all of these. I'm going to subtract 3 groups of 360. Okay, and this works out to be negative 340 degrees. Okay. Another type of question that you could get, write an expression for all possible angles coterminal with each given angle, and identify the angles that are coterminal and satisfy negative 360 is less than theta is less than or equal to 360, or negative 2 pi is less than or equal to theta equal to 2 pi. So we want to do 2 things here. We want to write the general form, because that's all possible coterminal angles. And we also want to find all of the angles that are between, okay. Where are we? We're getting close. Here we are. Between negative 360 and 360. Okay, so I'm going to start with the negative 500. That's outside of my domain. So I will start by adding 360 degrees. And that gets me to negative 240 degrees. And then I'll add from negative 240, I'll add another 360 degrees. And that gets me to 120 degrees. Now, if I added it again, I would be outside of this domain. So I'm going to stop here. But the general form would be 120 degrees plus or minus 360 degrees times n, where n is an element of the natural numbers. Okay. For 650, I'm too high. I'm above the 360, so I'll start by subtracting 360 degrees, and that gets me to 290 degrees. I'm running out of space here. And then if I subtract from 290, another 360, now I'm at negative 70 degrees, so I'm below 0. If I subtracted another 360 though, I'd be outside of this domain. I'd be too low. So I'm going to stop there. The general form here would be 290 degrees plus or minus 360 degree n, where n is an element of the natural numbers. Okay, and for 9 pi over 4, here I'm going to add or subtract 2 pi. So I know already that 2 pi is 8 pi over 4. So I'm going to subtract 8 pi over 4. And that gives me 1 pi over 4, or pi over 4. And if I go with pi over 4 and subtract another 8 pi over 4, that's 1 pi over 4 minus 8 pi over 4 is negative 7 pi over 4. And that's all that I'm going to get there. Okay, in general form for this one, it would be pi over 4 plus or minus 2 pi n, where n is an element of the natural numbers. Okay, and as promised, we are also going to talk about arc length. Okay, I mentioned this at the beginning, but we're going to come back to it now. Okay, so one thing that we need to sort of recognize when we're talking about arc length is, I'm going to take a circle with radius r. The circumference of that circle is 2 pi r. Okay. So that's one thing to sort of have in the back of our minds. Okay. If I take, and also, sorry, another thing, this angle over here is 2 pi, right? So if I do one full revolution, the central angle over there is 2 pi. Okay, now when I take a sector of a circle, this is my r, this is my theta, this here is the arc length. Okay, what we need to sort of recognize is that there's a proportionality that is true in these two pictures. And that proportionality is that the measure of the central angle over one revolution should equal the length of the arc over the circumference. Okay, so this length, essentially what I'm saying, is the ratio of this to this. That ratio is equivalent to this ratio, theta over one revolution. Okay, so let's translate this more into like math symbols, numbers, that sort of thing. The central angle we're going to call theta. We know that one revolution is 2 pi. That should equal the arc length A over the circumference, which is 2 pi r. Okay, now there's this common 2 pi in the denominator. So if I take the whole equation and multiply it by 2 pi, what I end up with is theta equals A over r. That 2 pi cancels. And this is an equation that we can use to relate that the measure of that central angle theta to the arc length and the circumference. Okay. This is a formula on your formula sheet. One thing that you need to know though is that this angle theta must be in radians. Okay, and the reason it has to be in radians is because when we put one revolution as 2 pi in the denominator, that's how we could cancel the 2 pi with the circumference on the right. Okay, so if we're ever working with degrees with this formula, we've got to convert. All right, so for example, an arc of 14.6 centimeters has a central angle of pi by 4 radians. Determine the radius of the circle to the nearest tenth. Okay, so we want to know here our formula is theta equals A over r. We want to know the radius. So what I'm going to do is I'm going to manipulate this equation to solve for r. So I'm going to start by multiplying both sides by r. On the left, I'm going to have theta times r is equal to A, and then I can divide both sides by theta, and I get that r equals a over theta. And now I can just go ahead and plug in my values, which is in this case 14.6 over pi by 4. And when you plug that into your calculator, what you end up with is 18.6 centimeters. Okay. All right, so here's a couple more questions. If A represents the length of an arc of a circle with radius r subtended by a central angle of theta, determine the missing quantity and give your answers to the nearest tenth. So here we know r, we know theta. Ooh, but theta is in degrees. So before we do anything, we need to take that 75 degrees and multiply it by pi radians over 180 degrees. And as an exact value, 75 over 180 is 5 over 12. So that's 5 pi over 12 radians. So that's the value for theta that we need to use. We're looking for A here. So we have theta equals A over R. So if I multiply both sides by R, I'm going to get theta times R equals A. So then that's what I'll plug in. 5 pi over 12 times the radius is 8.7. And that works out to be 11.4. And I just did that on the calculator. Okay. Here's another one. Theta equals 1.8. No units. So that would be radians. A equals 4.7 and find R. So we actually already isolated for R up here. So I'm just going to reuse that. R equals A over theta, which is in this case 4.7 over 1.8. And that works out to be nearest tenth, 2.6 millimeters. Okay, and then finally, oh, we got two more questions actually. R equals 5, A equals 13, theta equals what? So theta is A over R. And in fact, what I'm looking for in this case is theta. So I can just plug in my values, 13 over 5, and that is 2.6. Theta is 2.6 radians. Okay. Last question. A pendulum is 40 centimeters long. If the end of the pendulum swings through a total distance of 13.5 centimeters, what is the measure in radians and in degrees, both to the nearest tenth, of the angle through which the pendulum swings? Okay, so what I would do here first is draw it. If you're thinking about a pendulum swinging back and forth, okay, it's going to swing around, making an arc, and then swing back and forth and back and forth. Okay, so what we know here is that the pendulum is 40 centimeters long. That represents the radius of this sector. Sector is part of a circle. The arc length is 13.5. So we want to know theta. Theta is A over R. So in this case, that's 13.5 over 40. And that works out to 0.3375 radians. Okay, now we also wanted to convert this into degrees. So I'm going to take that 0.335, and radians, and I'm going to multiply it by 180 degrees over pi radians. Okay, so the radians cancel. And in my calculator, I'm going to do 180 times 0.3375 divided by pi, and that is 19.3 degrees. Okay, now we were asked to round to the nearest tenth, so here I'm going to round this to 0.3 radians, but I kept all 4 digits because I was reusing that value to get the degrees, and I wanted my degrees to be more accurate. Okay, so I'm going to leave it, oh, my dog is barking. I'm going to leave it there for now, and I will